Hello everyone, my name is Lee Martin and I'd like to welcome you today to our Steinel web seminar whereby I will be going through the details on our new interfaces with the new possibilities. Control Pro 2, new presence detector generation. From 5 sensors across 7 different communication interfaces, we have a complete range for building automation. You can see the range consists of the 7 interfaces of COM1, COM2, the Bluetooth input device, KNX, IP, and DALI 2 as an input device or an application controller, and across the range is our True Presence multi-sensor, our hallway sensor, our HO360-2, and our IR Quattro HD-2. So now we're going to have a look at the difference of the interfaces. So COM1. This is for switching the light on and off. Now this can be done by either presence control or absence control, also known as fully or semi-automatic. We can integrate a push button for the manual override, along with networking of the sensors for additional detection coverage. COM2, which is the same as COM1, but we have the additional parameter of control on the HVAC system. With the Bluetooth input device, this acts as a range extender for all of the other interfaces and sensors within the Control Pro 2 range, and purely provides the information relating to the presence and the brightness value. For DALI, we have the DALI 2 application controller, whereby via either broadcast or addressable, we are able to control up to 64 DALI devices, controlling up to 3 lighting groups, and we have the additional feature of the new multi-zone. This is where we can control separate luminaires from the 3 different DALI groups to create a special multi-zone scene. We can control the constant lighting for the room space, along with having a preset ambient basic light function. And like the COM1 and COM2, we have the fully and the semi-automatic with push button connection and networking. The DALI 2 input device works as a connection to a higher level application controller or a BMS system. These devices are providing the presence, the brightness, the temperature and humidity values of the room, and the multi-sensor is also able to provide the CO2, the VOC, and the air pressure too. For KNX, we can connect to 4 light channels and 2 constant light channels. We have the HVAC, the presence, and the absence control, and there is a threshold value controller for the temperature and humidity, along with the CO2, the VOC, and the air pressure that is found in the multi-sensor. We have a dew point alarm that is able to provide comfort for the client also. On the IP, we have power over Ethernet which is supplied, with connection interfaces of MQTT, BACnet, and REST API. Again, by using the sensor, we are able to provide the presence, brightness, temperature, and humidity of the room, along with the CO2, VOC, and air pressure found within the multi-sensor. So the basics of power over Ethernet. So the power is supplied directly via the networking cable. There's no 230 volt cabling required, and it's suitable for devices with a low power consumption. We have a maximum usable power at a class of 0, which means network port provides up to 13 watts of power. We have a nominal supply voltage of 48 volts, and the voltage is supplied either through PoE capable switches or PoE injectors. We can see in the bottom left, the first case, that the switch powers the sensor via PoE, whilst also transmitting data. On the second case, we have the switch transmitting data via the PoE, which is then, the ejector is then providing power to the sensor, and the transmission of the data is back and forth to the cloud or the server systems. So, IoT without detours. Now, due to the direct connection of the sensor technology to the IP networks, gateways or converters are no longer necessary that may have been required before. This means that the existing infrastructure within the building can mainly be used. and it's simple to monitor or test using IP-based hardware, such as a tablet or a laptop. We have seamless networking of devices from different manufacturers, and the IT security standards are still applicable. So REST API, Representational State Transfer, Application Programming Interface. And this is a machine-to-machine communication, and the data is exchanged via JSON format. An example of the data being transmitted is as per this slide here. We can see the sensor type is the HPD2, the message type, the app version, along with the detected persons, the persons present, and the different coding of what the sensor is providing back to the system. BACnet, Building Automation and Control Network. This is very widespread in building automation in the field of HVAC, heating and air conditioning. Each device is identified by a BACnet device ID, and this must be uniform throughout the entire installation. Sensor data is organized in standardized BACnet objects, and each object has defined properties based on the type of the object. The data can be read and written, and data is sent with a defined value when changes occur. We call this COV, change of value. All BACnet properties of the device are documented in a uniform document, PICS, the Protocol Implementation Conformance Statement. Here we have an overview of the BACnet interface, from the device object through to the analog input devices, the binary input objects, and the trend log objects. And lastly, with MQTT, this is a message queue telemetry transport. This is a very efficient machine-to-machine protocol based on TCP. We can publish and subscribe procedure, and there is a central broker. This is a central server which manages all messages. The allocation of the message is via the subject or the topic, and there's a hierarchy structure that can be used here. We have different service qualities or quality of service. This means that MQTT is also suitable for unstable connection, as there is acknowledgement of receipt. Functions such as last will and testament, retained messages, etc. offer further helpful options. So here is an example. In the top right, we have our HPD2. This is publishing data to the MQTT broker, which can be local or cloud-based. We then have in the top left the interested other devices. This may be a monitoring facility that subscribes to the topic, whereby the MQTT broker then publishes new data from the sensor to the device. So here we can have a look at the comparison of the protocols from BACnet to MQTT and the REST API. And all three protocols can be used at the same time to work the information better together. The future is Bluetooth. Next year, Steinel will have a Bluetooth IP gateway that can create a connection between Bluetooth mesh and IP networks. The data in the Bluetooth network can be read and written, and the IP side access can be done via protocols, again BACnet, MQTT, and REST API. With the Steinel Dialog Days, you are able to create your own schedule and choose from one of the 20 different sessions available. From the DALI 2 know-how to the hotel industry sensors and the basics on our true presence technology that can detect the smallest of movements, including breathing within the room. Thank you for your time. Now it's your turn to ask any questions you may have from today's webinar. Please feel free to ask your question in the live chat, and we will answer this as best as we can for you. Thank you again for your time and your questions. Please do not hesitate to get in contact with us in the UK. We can help you from relux planning in selecting which sensors to use and where. We can assist you in site visits from one of our project sales managers, or even if you're just wanting information from us in regards to our Prologue, a unique device that can calculate the energy savings that could be made by the implementation of lighting controls to the building. Thank you again for your time and attendance, and we wish you a good day. Thank you.